Okay, so we're going to work for solving inequalities, and to solve an inequality, it's exactly the same as if you were solving an equation. It's just that we have these symbols we have to worry about, and there's only one situation, or well, two, that it matters about that inequality sign where it will change direction. So we have greater than or equal to, less than, and less than or equal to. So we're actually going to skip this page. You can go through and work on it if you would like to, but we're going to go ahead and skip over it. You can check the key on Canvas. And we're going to solve some basic inequalities first, and then we'll go through the rest. So the first thing, the big thing, the only difference between inequalities and equations when it comes to the steps of solving, if you're multiplying or dividing by a negative number, the inequality symbol will flip. So I want you to go ahead, and we're going to just skip around on this page. So I want y'all to do C, D, that's supposed to be a 3, F, and G. So I'm going to give you a few minutes. Go ahead and get those done. Okay, so for C, we're solving it just like normal. We're subtracting 2 on each side. And it's -7. The sign doesn't flip because we didn't even multiply or divide in that equation, or in that inequality. For letter D, we're going to be dividing by 3 to get x by itself. And that is -4. And then when it comes to the symbol, the number we're looking for to see if it is the negative number is what we're dividing by. So since 3 is positive, what we're dividing by, our symbol isn't changing. It's going to stay as less than or equal to. Then over here for F, it's x divided by -2. So to undo that, we're going to multiply by -2 on each side, which then means we have x, and then -7 times -2 is a +14. And this time we multiplied by -2. That's the negative that makes a difference. So our symbol is going to flip sides. And then the last one from this page that we are going to do together as a class is letter G. Now with G, I notice a bunch of y'all just kind of skip over fraction ones, or those are the ones that make it harder for you. They're really not that bad, and we can take it as 2 steps. So if you are really good at fractions, you know fractions, they don't bother you whatsoever. You know to multiply by the reciprocal, and that is your 1 step and you're done. Let's say you're not so great at fractions. That is also totally fine. To multiply or to get rid of that fraction, we're going to do it as a 2-step problem. So our first step is going to be multiplying by 3 to get rid of that denominator. And then we're left with 2x is less than 24. And then now it's back to those easy steps of dividing by 2, and it was all positive, so x is less than 12. Okay, so we're going to go to the next page. On the next page, we're solving our 2-step inequalities, and we're not going to do all of these either. We're going to go through a few of them, and then the rest are going to be for you to just practice later. B, D, and E are the ones that we're going to work on together. So on B, we're solving it just like normal. It's going to be our 2 steps to solve it, just as if it was an equation. So move our constant first. If we're moving the constant of 8, we're left with -3y is greater than or equal to 21. And then we're dividing by -3. Okay, and now for this one, we were dividing by the negative. That was the part that was actually doing the division part, so we are going to flip our sign. Y is less than or equal to -7. Okay, for letter D, our first step, we're going to distribute that -4 out to get -8 plus 4x. Be careful with that symbol. It should be a plus. And then we're going to do what we've been doing before, move the constant and then move our coefficient. So adding 8 to each side to get 4x is less than or equal to 16. And get rid of the coefficient by dividing by 4, and x is less than or equal to 4. There were no negatives when it comes to multiplying and dividing, so it's not even a part we have to think about. On the last one, we're going to go through the steps of getting rid of the constant first, and then we'll get rid of the fraction. So adding 5 to move that constant to get 3/4 x is less than or equal to 12. From there, we want to get rid of the fraction, so multiply by the denominator. So 3x is less than or equal to 48. And dividing by 3 as our last step. Again, all of that is positive, so we don't even have to think about a flip. And here's our answer. We're going to touch on F actually before we skip over. On letter F, you can work through all of this with the fractions. That is 100% fine if you would like. If you want the fractions to disappear, so we want that fraction gone, that is also okay. If we want to get rid of the fraction completely, so to get rid of the fraction completely, I'm going to change the fractions to be equivalent fractions, but make them all have the same denominator. I want them all to have the least common multiple as their denominator. So instead of a denominator 3 or 2, I prefer 6, but we want to maintain the integrity of the fraction. So this is going to be 4/6, because that's equivalent to 2/3. This is going to be 3/6, and this is going to be 2/6. All of those are still equivalent. It's just to kind of help us get rid of the fraction if this is something you know that you're better at instead of having to work with fractions the whole time. Because then we can multiply the entire inequality by 6. And we're going to get 4x plus 3 is greater than 2. And then now it's a little bit easier for us to go through and solve. To get 4x is greater than -1 and dividing by 4. Now, since we're dividing by a positive number, the inequality is not going to flip. So x is greater than or equal to 1/4. That's a 4 in the denominator. Okay, on to some special cases. So with special cases, we had them yesterday with equations, so we're going to look at them again with inequalities. It's the same idea, though. It's when a variable disappears and we're left with a true statement or not a true statement. So if we look at letter G, we would subtract x on each side, and the variable is disappearing. And we're left with 5 is less than or equal to 3. I don't know about you, but in my math world, 5 is not less than or equal to 3, which means this is not a valid statement. Since it is not, we are going to say there is no real solution. Okay, we're going to do it again for letter H. It's another kind of special case. Notice we have two variables on the same side, so let's combine those before we keep moving. And then we're going to move, we have variables on either side now, so we're going to subtract 2x, and the same thing is happening where those cancel. And now we have that -2 is greater than -5. Now let's think about that for a second. -2 greater than -5. We have negative numbers, so this is actually a true statement. Since we are left with a true statement, we have the same as what it was yesterday, that it is infinite solutions. And then we're going to skip that last one. just because those are only two special cases that we're really going to see. Okay, so the last thing that we're going to do together as a class or together for these problems is a real world application, so a word problem, and then we're going to solve it. So to rent a certain vehicle at Rent-A-Ride, they charge $55 per day with unlimited miles. The cost of renting a similar vehicle at We Got Wheels is $38 per day plus 20 cents per mile. For what number of miles is the cost at Rent-A-Ride less than We Got Wheels? So we have Rent-A-Ride and then We Got Wheels. So it's asking, when is it that this one is cheaper than the We Got Wheels? So looking at the Rent-A-Ride price. Rent-A-Ride just charges $55 no matter what. So that doesn't have a variable that's attached to it. It just charges you $55 a day. There we go. If we look at Wagon Wheels prices, they cost per day and 20 cents per mile. So theirs is the $38 a day plus the 20 cents per mile. So when is Wagon Wheel going to be more expensive? So breaking this down and solving it, well, we're going to subtract 38 on each side. So 17 is less than that 20 cents per mile. And then dividing by our 2/10. So what we just figured out, m is greater than or equal to 85. That means for what number, our answer is going to be that it has to be greater than, greater than 85 miles. Now something to note here, we are not going to write that the answer is 86. The reason we're not going to write the answer as 86 is because it's possible to have part of a mile. They're allowed to drive 0.1 of a mile. I'm sure that any company is going to charge them for partial miles as well. So we're not just going to round or go up to the next number and say 86 miles or higher. It's going to have to just say it's greater than 85 miles. That's something to keep in mind when we do these word problems with inequalities, is that we can't restrict it to just saying the next number no matter what. There's always that option of fractions or decimals or whatever that is. So truly just stating that or writing it out in words of what those miles or what that answer is representing. Okay, so we skipped a decent amount of these problems, and that's just for you to go back and practice. The key is going to be posted on Canvas, so by all means get that extra practice in and make sure you're feeling comfortable with solving inequalities.